Hello students, today we are going to study motion under gravity. This chapter is very important part in kinematics. After studying motion under gravity, it is very easy to understand projectile motion and other chapters in mechanics. So let's start motion under gravity. Motion under gravity is a special part of motion in one dimension where a particle will be projected either vertically upward or will be thrown downward from some tower or from some height. Okay, so let's understand how displacement, velocity, acceleration and other calculations are done in case of motion under gravity. So let's start. Let's start motion under gravity. Dear student, first of all, we will study when a particle is projected vertically upward from ground, okay, with some velocity u. And these are our sign convention. This is the sign convention for displacement. The point of projection will be taken a 0, and upside to the point of projection we will take positive, and downside to the point of projection we will take negative. Okay, and dear student, now talk about the sign convention for velocity. Upward direction we will take velocity to be positive, and downward direction we will take velocity to be negative. Okay, and same is the sign convention for acceleration also. So I am writing here acceleration and velocity. Okay, in upward direction here we will be using j cap, and in downward direction here we will be using minus j cap. These will be our sign convention. Okay, so let's start. When a what happens when a particle is projected vertically upward with velocity u? Okay, dear student, we are projecting a particle vertically upward with initial velocity u from ground. First of all, we will calculate time taken by particle in attaining maximum height. We know at maximum height velocity will become 0. Okay, so we will apply first equation of motion. This is uniform acceleratory motion. Let us assume thus P is the highest point. We are assuming. Let us assume P is the highest point of trajectory. Okay, and this H is the maximum height. So dear student, when we apply first equation of motion, V equal to U plus AT, let us assume time taken by particle in moving from point G to point P is t dash. Okay, so velocity at highest point is 0. Initial velocity uj cap, acceleration due to gravity can be written as j minus j cap into t dash. After solving this equation, we get t dash equal to u upon g. So dear student, time taken by particle in moving from ground to highest point is u upon g. Okay, and understand this concept in a very simple way. Suppose acceleration due to gravity is 10 meter per second square. What does 10 meter per second square indicates? 10 meter per second square means 10 meter per second for any upward projected body. its velocity will get decreased by 10 meter per second every second. Or for any downward projected body, its velocity will get increased by 10 meter per second every second. So what happens? If you throw a particle with 50 meter per second, it will attain its maximum height in 5 seconds, because every second it will lose velocity by 10 meter per second. Okay. So if you are throwing particle with 50 meter per second at a constant rate of 10 meter per second, it is losing the velocity, so it will attain maximum height in 5 seconds. Okay. If you throw a particle in with 60 meter per second, it will attain maximum height in 6 seconds. Okay. So dear student, it is very simple, or you can also apply this formula. Time taken by particle in moving from ground to highest point is u upon g. Okay. Now dear student, we will be looking for the maximum height. This is h. For the calculation of maximum height, you can use second equation of motion as well as third equation of motion. Both will give you same result. Okay. But if you apply second equation of motion, it will take more time in calculation. But if you apply third equation, it will give you quicker result. Okay. So dear student, let's see both the thing. We are applying second equation, hj cap equal to uj cap into t plus half g minus j cap into u upon g whole square. So dear student, after solving this, we get u square upon g j cap plus u square upon 2g minus j cap. So this can be written as h equal to u square upon 2g. This is maximum height. Or you can write, this is the simple result of uniform accelerating motion, that average velocity in given time interval is what? Initial velocity plus final velocity divided by 2. Okay. And what is displacement? In case of uniform accelerating motion, displacement in given time interval can be written as average velocity into time interval. So dear student, you can see this. Initial velocity was u and the final velocity of the particle at highest point is 0. So what is average velocity? U plus 0 upon 2. This is average velocity into time interval. Time is how much? U upon g is 6. So this is the maximum height. So in this way also you can calculate maximum height. Okay. Dear student, if you apply the third equation of motion, it is very simple. Okay. Now apply third equation. V square equal to u square minus 2gs. See here how quickly you can get the maximum height. It is very, very simple. This is the maximum height attained by the particle when it is thrown from ground with velocity u. Okay. You throw particle from anywhere with velocity u, it will attain height u square upon 2g in a general way. Okay. So this is the general thing. Now dear student, we will find time taken by particle in attaining some position at a particular position. When you throw a particle from ground at a particular position, particle will be at two time, during upward journey and during downward journey. We will calculate both the time. Okay. So let's see. See, this is very interesting part. Now we are throwing the particle with velocity u. From ground, and this is the highest point. Dear student, let us assume this is point A somewhere at height h. Okay. Not necessary at midpoint. This is some height. Okay. H. The particle will be at two time here, during upward journey and during downward journey. Now we are writing the general equation for height h. Okay. Dear student, if we write the general equation, we will get h equal to what? Ut minus half gt square. This is a quadratic equation which will give you two time. Okay. One for the upward journey and another for the downward journey. Okay. You can solve both the time. After solving this equation, you will get gt square minus 2ut plus 2h equal to 0. So t will give me 2u plus minus under root 4u square minus 8gh upon 2g. We are taking 2h LCM. So we get u plus minus under root u square minus 2gh upon g. This is a general equation for time. Okay. Now we will get here two values for time. Okay. One for G2A and another for G2P and P2A. Okay. So what is that? Those two values? See here. This is, let us see first value, and let us assume this is second value. This is highest point. So dear student, what is T1? T1 is u minus under root u square minus 2gh upon g. And what is T2? This is T2. T2 is what? U plus under root u square minus 2gh upon g. This is T2. So dear student, now very interesting results you are going to see. See, this is T1. From G to A, this is T1. G to A to P, and P to A, this is T2. Okay. Now, time taken by particle from A to P will be how much? See, if you take difference of time T2 minus T1, this will give you how much? This will give you time from A to P and P to A. This is equal to how much? This is equal to 2 under root u square minus 2gh upon g. Okay. This is T2 minus T1. Dear student, particle it will take same time from A to P and P to A. So from A to P, what is the time? From A to P, the time is u square minus 2gh under root upon g. This is the time taken by particle from A to P. Okay. So dear student, you have seen what happens when a particle is thrown vertically upward with velocity u. Okay. We have calculated maximum height, we have calculated time taken by particle in moving from ground to highest point, and we have calculated two time when particle will be at the same position. Okay, dear student. Now we will see what happens when the particle is dropped from some height. Okay. When particle is dropped from a tower dear student, let us see the particle is dropped from height capital H. And this is ground. Initial velocity is 0. This is point P and this is ground point. So what happens when the particle is dropped from point P and when it reaches to point G? This is equation of displacement H minus J K equal to half G minus J K. Let us assume time taken is T1. So dear student, how much is T1? T1 is under root 2H upon G. And what is this velocity? When velocity of particle just before hitting the ground. From third equation is how much? V equal to under root 2GH. So you can see here, this is V upon G. Okay. So dear student, this is the time, okay, and this is the velocity just before hitting the ground. Now what happens when the particle is dropped with some velocity downward or upward? Okay. When the particle is dropped with some velocity u downward from height h. So dear student, directly I am telling you, if v is the velocity just before hitting the ground, this will be how much? This will be u square plus 2gh under root. And what is time? The time taken by particle will be equal to v minus u upon g. This will be the time. Okay. Now I am telling you the short trick for a particle when particle is thrown vertically upward from height h. Okay. Dear student, if v is the velocity just before hitting the ground, this will again be same, u square plus 2gh under root. Now here time will be how much? Here time will be v plus u upon g. So dear student, if you write this time as t2, this time as t1 and this time as t0, okay. Let us assume this time as t0. So general relation is this, t0 equal to this also you can prove. This is t1, not earlier one, okay. This is t1 and this is t2 and the t0 was under root 2h upon g, okay. So dear student, in the next lecture we will see many problems and many important results, okay. Thank you.